myself Yogesh. I'm gonna present my topic on Wood and Armour's method and seismic behavior of beam column joint. At first, Wood and Armour method. This method is used for designing slab while that particular slab is in twisting. This method was developed by considering the normal movement yield criterion to prevent the yielding in all direction of that particular slab. At any point in the slab, the movement normal to the direction resulting in designing movement should not exceed ultimate resulting movement in that particular direction. Whereas the ultimate normal resistance movement is typically provided by ultimate moment resistance related to the reinforcement in the direction of x and y or x and phi directions, that is mu x and mu phi. Here mu x and mu y and mxy are bending and twisting moments, where mxy is the twisting moment usually obtained from the finite element or by using Grillage analysis program. The sign conversion needs to be altered if the different from above. Phi is the angle of transverse steel measured in clockwise direction. Mx, that is movement to be resisted by the reinforcement in the x direction, whereas m phi movement to be resisted by reinforcement in phi direction. And this method is used from the reference concrete bridge design, and calculation may be carried out by the following procedures below. All calculation proceed after the determination of movement field, and the equations in a form that is translated directly to the spreadsheet format. There are two reinforcement, that is top reinforcement and bottom reinforcement, to determine the wood armor's moment. In this method, mxt1, that is movement along the direction x, and m phi t1, that is movement along the y direction. If this mxt1 is less than 0, section is in x direction sagging part. Same as suppose for m phi t1 is less than 0, then section in y is in sagging part. For by all calculation we will get this particular part, same as for the bottom sagging, bottom reinforcement, that is nothing but sagging. If mxb1 is greater than 0, it tends to in x direction, whereas suppose mfi is in y direction, it's supposed to sag. See, then as comes seismic behavior of beam column joint. Beam column joint connections. Connection is one of the important part of that particular structure. The portion of column are the common to beam in their intersection are called beam column joint. In this particular image, the beam column joint should be of method strong column weak beam concept to resist high strength in earthquake. These joints have limited force carrying capacity. The force larger than these are applied during the earthquake. Joints are severely damaged. Repair damage joints is difficult, so damage must be avoided. Under the earthquake shaking, the beams adjoining a joint are subjected to movement in the same direction. If that particular earthquake is in same direction, the building tends to in a shear part, so there will be a loss of grip on the beam bars in that particular region. If this particular shaking will occur in other direction, it tends to distortion will occur in both at the upper part, that is compression part, and the tension part. This method is usually called as pull-push forces on joints, reinforcing the beam column joint. For this, as I said, strong column, weak beam concept, using large column size is more effective way of achieving this. In addition, closed loop, that is closed tie, should be provided nearby the joint to hold together concrete in joint region and to resist shear forces. Intermediate column bars also are effective in confining the joint concrete and resisting the horizontal shear forces. As I said, the tie should be provided nearly about 150 mm spacing, not more than 150 mm spacing, and the anchorage part, that should be of the size of anchorage part should be 10 times the diameter of the tie as per the IS code 139201993. This is one of the ductility Indian standard code. In that particular code require building in different seismic zones 300 mm wide in each direction of cross section when they are supported beams that are longer than 5 meter, when these columns are taller than 4 meter between floors. As per the American standard, 20 times the diameter of largest longitudinal bar used in adjoining beam. As this figure shows, this is the wide column and the L-shaped bar is used for that particular reinforcement. It is preferable to have column with sufficient width, such as approach in many codes. In interior joints, the beam bars, that is both in top and bottom, need to go through the joint without any cut in the joint region. These bars must be placed within the column bars and with no bends. As this particular figure shows, beam bent in adjoining region overstress the core concrete adjoining the bends as it bends. This is one of the poor detailing of that particular column. Here it shows the beam bars with the column bars are also straight. It is one of the good practice. And one of the innovative techniques are RC beam column joint strengthening by FRP wrapping. Strength of the beam column joint with steel fiber reinforcement concrete during earthquake loading. Reinforced concrete movement resisting frames. The conclusions are closed loop and intermediate column resisting ill effect of distortion of joints. Greater width of the column should be provided. Beam bars within the column bars should be straight, and L-shaped bars bent for large columns. These are the references which I used for this particular presentation. Thank you.